Review question number 13 from our packet. Solve the following exponential and logarithmic equations. You can see it has 8 parts to it. Lovely. All right, let's jump in here. Part A. 3 to the 8 minus 2x is equal to 81. All right, for part A, we're going to use the Bros rule here. We're going to try to get the same base on both sides. 3 to the 8 minus 2x, I'm not going to change. On the right side, 81. 81 is 9 squared, and 9 itself is 3 squared. So really, this is like saying 3 to the 4th power. And look, I have the same base now on both sides. So I can drop those bases and simply say that 8 minus 2x is the same as 4. And then solve it normally. So I'm going to bring the 2x to the right. I'm going to bring the 4 to the left. That's going to give me 4 equals 2x. Divide both sides by 2, and I have x equals 2. So there's our first answer here. X equals 2. All right, for the next one, I'm going to have to take advantage of a log or a natural log to solve because there's no way to turn 17 into a base of 4. So in our case, we're going to take the ln of both sides. So I'm going to have the ln of 4 to the x equals the ln of 17. Again, by taking ln allows me to bring the x in front. And so I have x ln of 4 equals ln of 17. Then I'm going to divide both sides by the natural log of 4 so I can get my result. So x is equal to, and this is the calculator comes in handy. So we've got natural log of 17 in our numerator divided by natural log of 4 in our denominator. And it looks like the answer is 2.044. We'll go 3 decimal places here. 2.044. And we'll put that right here. X is equal to 2.044. All right, for the next one, again, we can take advantage of the Bros rule. How can we do that? Well, again, it's 6 and 36. I'm pretty sure we can get those to be the same base on both sides. So 6 to the 2x plus 6 equals 36 to the x. So our left-hand side doesn't change. That stays 6 to the 2x plus 6. The right side, though, 36 is 6 squared, and that's being taken to the x power, which really means that it's 6 to the 2x here. So 6 to the 2x plus 6 equals 6 to the 2x power. Now we can stop here because if we lost the 6's, we'd have 2x plus 6 equals 2x, which means the x's are going to cancel, which means this doesn't have a solution. So you can say no solution. You can say the null set, right? It doesn't have a solution. All right, part D looks like we're also going to be able to take advantage of the Bros rule again here. 49 is 7 squared, and that's being taken to the negative x plus 6 power, and it equals 7 to the x power. Now we can distribute this negative 2, so this left-hand side is really 7 to the minus 2x plus 12 power equal to 7 to the x power. Again, once the bases are the same, we lose the bases. So what we're going to see is negative 2x plus 12 is the same as x. If we bring the 2x to the right, we're going to have 12 is equal to x plus 2x, or 12 is equal to 3x. When we divide 3 on both sides, it looks like x is going to be equal to 4. So we can put that here for part D. X is equal to 4. All right, which leaves us E, F, G, and H. All right, for E, we're going to take care of, and we're going to use the definition of log, which says 25 to the power of 1/2 is equal to x. Now, the square root of 25 is the same as the 25 to the 1/2 power. And so we're going to say 5 is equal to x. Normally, we might say plus or minus 5, but remember, x cannot be a negative value. So 5 is the answer for part E. For part F, once again, same thing as we did in part E. The definition of log is in the 5 is our base to the power of 1. So 5 to the 1, which of course we know is 5, equals 3x minus 7, which means that 5 equals 3x minus 7. So we bring the 7 over, so it's going to be 5 plus 7 is equal to 3x, which means 12 is equal to 3x, dividing by 3, and once again we have an answer of 4. For part F. All right, for part G, we've got to consolidate these logs before we can try to use the definition to solve them. Now, plus means a multiplication. So what it means here in part G is that we have log base 4 of x minus 2 times x minus 2, or x minus 2 squared if you like, equals 1. Alrighty, I like this one. I think we can use this, because what this means is 4 to the power of 1 is equal to x minus 2 squared. All right, now x minus 2 squared is the same as x squared minus 4x plus 4. All right, and if we bring this 4 from the left to the right, we're going to find that that 4 and this 4 cancel each other out. What we're going to get instead is that 0 equals x squared minus 4x. Now, if we factor an x out of that, that's going to have x times x minus 4, which tells us the answer is going to be x equals 0 and x equals 4. So then the question remains is, can we have a 0 for our x? And here's the problem. We cannot, because if we put a 0 in for x, we're going to see 0 minus 2, which is really negative 2, and you can't have a value that's negative. So even though we got it, we can't use it. So this is the only value we get for that one. All right, now we need to make things a little bit smaller since I've used up so much room here. So before we can attempt part H. All right, thanks to the magic power of paint, I have gone ahead and minimized some of our work. It's still here, just a little bit smaller, so we have more room to work. All right, in part H, we have log, no base, right? It does have a base. Its base is 10, remember. It just doesn't say that. All right, we have a subtraction. We have another log here as well. All right, so if we can get the same base of log on both sides of this problem, we can solve it. So let's consolidate the left-hand side first. This becomes a division. We have 1 log. We're going to have x plus 10 in the numerator. We're going to have x plus 4 in the denominator, and it's going to equal log x on the other side. Now we have the same base of log on both sides here. So we can lose those logs and set the rest equal. So x plus 10 divided by x plus 4 is the same as x. We'll cross multiply here. So x plus 10 stays on the left, and when we multiply x times x, we get x squared, and x times 4, we get 4x. We want to bring everything on the left to the right and set it equal to 0. So 0 equals x squared plus 4x minus x minus 10, or 0 equals x squared plus 3x minus 10. Thankfully, the factors of 10 that add up to 3 are 5 and 2. It's a negative here, which means one's a plus and one's a minus. The 5 is going to be the plus, and the 2 is going to be the minus. And that's going to tell us that x equals negative 5 and x equals 2. All right, once again, we go back to the original here and we put in these values. Would it produce a negative anywhere? If I put 2 in, 2 plus 4 is 6. 2 plus 10 is 12. 2 is a good value. Negative 5. Negative 5 plus 4, oh, that would be a bad value because negative 5 plus 4 makes negative 1. So this, again, is a value we cannot consider. So the only answer then is going to be that 2. It had 8 parts. That was a lot. I know. You probably feel like you just gave birth to a mathematician. But there you have it. Number 13 from the review pack.